Now let's go through the rules for derivative on slide 6, 7, 8 and make our life easier a bit with some examples. So first thing, if A is a constant, first rule, then the derivative of A with respect to x equal to 0. Because it's a constant, it will not change, doesn't matter how x change. Example, not so necessary, but let's just go through it. If f equal to 3, always, then the derivative of f with respect to x equal to 0. Can be any other constant. The second thing again, if a is a constant, then the derivative of x to the power of a with respect to x will be, put a in front, times x to the power of a minus 1. Example, if we have, let's say, f x equal to x squared, then the derivative of f with respect to x equal to times x. But actually x here, the power of 2 minus 1 equal to 1, right? But you can just write 2x. The third rule. Now if we have a constant time a function of x, then the derivative of the result, the product, time fx with respect to x will be a times the derivative of that function with respect to x. Example, again, if we have 5 times x squared, which is the fx we have above, with respect to dx, with respect to x, sorry, over dx, will be equal to 5 times 2x equal to 10x. The fourth rule, so if we have the natural log of x, this is not really straightforward, but right now we just remember it, then the derivative of the natural logarithm of x with respect to x will be 1 over x. Alright? And if we have a constant like before, then of 5 times the natural log of x, then we have 5 over x. The fifth rule, here we have x to the power of a, now come a to the power of x. The derivative of that with respect to x would be a times x itself, and then times the natural log of a. Example, if we have the derivative of 5 to the power of x with respect to x, that would be 5 to the power of x itself times the natural log of 5. So you can use a calculator to calculate the numerical result of that. When necessary, a special case is we have the derivative of e to the power of x. You know what e is? It's the Euler number, right? With respect to x would be e to the power of x itself. So where does this part go? Where is it? So we have the log, we can say the log of the natural log of e here, of course, but you know the natural log of e, which is the log of e, but with the base also e itself, and that is 1. So at the end the result will be x. Next rule. Now we move to a bit more complicated cases where we have, let's say, two functions and gx, which are differentiable, which means there exist their derivatives. Rule number 6, we have the derivative of the sum of the two functions fx plus gx with respect to x will be simply the sum of the derivative of f and the derivative of g. So here it should be x. Alright. So let's say we have example fx equal to 6x squared and gx equal to 4x. So the derivative of 6x squared plus 4x with respect to x as usual will be the derivative of the first one, 6 times 2 times x to the power of 1 plus the derivative of the second function, 4x, so it's 4, right? So at the end that equals 12x plus 4. All right. The seventh rule. Now what is the derivative of the product of two functions instead of the sum? So the derivative of fx times gx with respect to will be, watch out, the derivative of first function times the second function itself, and then plus the first function itself times the derivative of the second function. So that's how it goes. Let's take the example gx and fx like before. So in this case we have the derivative of six x squared times 4x with respect to x. That would be the first derivative, 6 here, 12x times 4x. Then plus the derivative of the second one, 4 times the first one, 6x squared, right? Equal to 12 times 4, 48, x squared, plus 4 times 6, 24, x squared, which is 72, x squared. Right? Now, for such a simple function, you might ask yourself, how about we take, for example, the derivative of, we factor out those functions together, so 6 times 4, 24, x to the power of 3, with respect to x, that means 3 times 24 times x squared also, right? This only works when you have such simple functions. When the function gets more complicated, then the rule will be something that helps you through. Now there comes the last two rules. Number 8. So we have seen how it works for the product of two functions. Now it's about the quotient. So let's say we want to take the derivative of fx divided by gx with respect to x, right? So it will be two parts. The result will also be a quotient. On the denominator, it will be the derivative of f times gx minus the derivative of gx times fx. All right? And then in the denominator, the numerator, that will be gx squared. Using the same example that we have before with two functions, let's do an example. Let's say we want to have the derivative of 6x squared divided by 4x with respect to x. So here you might already realize that we can just simply simplify the functions and then we take the derivative. But yeah, let's save it for later and assume we also have a very complicated function. Like I said before, we just follow a rule, then see what happens. Okay, so the first thing is the derivative of the f, 12x times 4x, the second function itself, minus the derivative of the second function, 4 times 6x squared, right? And then everything divided by 4x. Everything in bracket and square. So now let's say 12x times 4x, 12, 4, 48, again, x squared minus 24x squared. And then here we have 16x squared. So what would it be? 48 minus 24, we have 24x squared on the numerator. And then 16x squared in the denominator. So we can just simplify it and simplify further by divided for 8. So that would be 3/2. And now imagine here we have something like simplified directly. So here and x. So we would have something like d of times x with respect to x. So it's actually the same thing. Last rule. Now imagine we have a function h of some variable z. Now let's don't write it like that, but rather h equal f z, function of some variable z. And then we even also have in turns z is a function of some variable x. How do we find the derivative of the function hx? There's a rule called chain rule, or outer times inner. So that means first we take the derivative of f z, but with respect to z. And then times the derivative of z x with respect to x. So let's say imagine we have a function like h equal to 1 over 4x. We can actually rewrite it in a way that equals 4x to the power of minus 1 when we bring it up to the numerator. So now the derivative of h would be the first thing. Okay, we treat 4x as a single variable. We take the derivative of 4x. So that would be, the power goes in front, minus 1 times 4x to the power of minus 1 minus 1 minus 2, right? And then times the inner, the derivative of the inner part, now in turn. So that would be 4. So to simplify everything at the end, we have minus 4, put this back again, 16x squared, and as a result that is minus 1 over 4x squared.